Ghost of Kennewick Man. Yeah, because the reason, first of all, I kind of stumbled across this article. I was asking AI to give me the the um, the most cited, peer-reviewed article on Kennewick Man, um, and it gave me this. You know what I'm saying? And it's very interesting because it gives a totally different account of what the original, if you want to call it the original, but I guess the most peer-reviewed study indicates, which is just continuation genetically with modern Native Americans, which gives the detractors of Black Indigenous ancestry the ammunition to continue to say, well, this means that there were no so-called Black Indians present within the American land masses, and if they were called Black, it was very ambiguous, and it could have meant just some dark skin people related to the same bloodline that the Siberian migration came from. So and I know a lot of people like myself are somewhat suspicious about these genetic results because the morphology speaks to something very different than what we see in modern Native Americans. However, even that, two things can be true at the same time. You know what I mean? By continuation, they're mainly talking about or referring to unilateral markers. Unilateral markers do not indicate, they do not indicate full ancestry. They don't determine full ancestry, and they don't measure admixture either. So, however, at least when I run it through AI, of course I haven't seen every single article on Paleo Americans that are available, but to my knowledge, even the autosomal makeup is coming up as non-mixed, and just a straight up continuation autosomally is in terms of what I've seen, and I haven't seen them all, which is very suspicious as well, because morphology is a direct reflection of autosomal makeup. You know what I mean? So if these remains are looking the polar opposite of what Native Americans are, then that should raise some questions, and it does raise questions amongst the academic community, the scientific academic community. But the results keep coming back the same, which is very peculiar. You know what I mean? But as we have it here, I've stumbled across an alternative article with alternative conclusions genetically in terms of DNA results for this specific specimen. Okay, so this is what this is about here, and we're gonna get into it. This is the Ghost of Kennewick Man coming back to haunt him, because originally Kennewick Man was determined to be non-Native American descent. This was before his DNA was analyzed, and based on morphology, they were heavily considering more than one ethnic group present in ancient America. But after the genetic sequence of the DNA, they determined that it was just Kennewick Man was just ancestral to Native Americans, which had many people scratching their heads. And this article aims at at least in my determination, pointed out the what could be biased approaches to DNA analysis, which could be the reason why all of these extreme polar opposite DNA results are being found. So, well, anyway, man, let's get into it, man. I'm gonna share the article. I'm gonna read it word for word. I'm gonna read the whole thing. We're gonna break it down. I got my Gemini set up, because for whatever reason I'm having trouble with my chat GPT, man. I'm gonna figure that out, just like I figured out the StreamYard. Well, really, I didn't figure it out. I had a good friend of mine that sent me the link, man, and yeah, man, shout out to him, man, and I might even drop his social, man. Let me see here, because I got some stuff that he sent me, and let me make sure I give him a shout out, because he has very similar material on his page as well. So I'm gonna give him a shout out. Don't see this info popping up in my messages right now. That's strange. Yeah, here he is. All right, man. Glenn, shout out, man. His channel was called, let me see here. Anyway, I figured out what his channel was called. I'll go to it before the end, man, and make sure my guy gets his shout out, man, because my guy Glenn made sure I got the proper link to StreamYard, so I can keep beating on these detractors' heads, man, the right way. And so if the detractors and the haters got a problem with these presentations, man, you'll have to blame Glenn, man. Because Glenn gave me the link, man, to bust y'all heads with, man. So it's Glenn's fault, man. Hopefully he'll find that comical, man, when he hears the presentation, man. But thank you, bro. Anyway, let's get on with it, man. This is the alternative conclusions to Kennewick Man's DNA results, man. So I'm gonna read let's read the author of the study. Hopefully I'm pronouncing this correctly. Daejon Wan and Shi Huang. Hey, man, did the best I could, man. Let's look up these names, though. I'm gonna ask, who is... I'm just gonna copy and paste this, man. Gonna keep it real simple, man. Oh, you can't copy and paste on there. Okay, we'll just write the name in then. I had to do it the wrong way. In the scientific realm. So let's see what the credentials are. Okay. That's interesting because, when I asked ChatGPT, said that, this individual was not a geneticist. It says here in the scientific realm, Jean Wan is a molecular geneticist and researcher whose work spans evolutionary genetics, complex human disorders, and clinical prenatal diagnostics. His research profile primarily splits into two distinct chapters: unorthodox evolutionary biology and clinical medical genetics. Let's see if it's got it wrong. Look like it do. Here we go. Evolutionary genetics and macroevolution. A significant portion of Wan's public-facing academic footprint is his collaboration with geneticist Shi Huang at the State Key Laboratory of Medical Genetics, Central South University, China. In this space, Wan acts as a challenger to mainstream evolutionary theories, specifically focusing on the maximum genetic hypothesis. Wan has co-authored several papers championing the MGD theory as an alternative to the traditional neutral theory of molecular evolution. This framework argues that genetic diversity eventually reaches as selection maintains saturation level, questioning the linear assumption of molecular clock. The University of Genetic Equidistance. The University of Genetic Equidistance. His work has reinterpreted the decades-old mystery of genetic equidistance, where distinct complex species appear equidistant to a simpler outgroup, arguing that complexity rather than time, since divergence is the primary driver of nucleotide level. Alternative human origins. Scroll down a little bit. As seen in his paper on the peopling of Americas, which is what we're about to read, Peopling of the Americas, Molecular Evidence for the Paleo-American and the Solitron models, Wan utilizes the MGD framework to re-examine ancient genomes like Kennewick Man and Anzac 1. He uses slow evolution SNPs to argue in favor of complex multi-directional migrations, including ancestral links between early Americans and Australasians and Europeans, which fundamentally clashes with mainstream out of Africa and Bering Strait only migration timelines. Okay, let's keep reading. This is interesting. Didn't expect this. Clinical medical genetics and disease prediction. On the traditional medicine side, Wan focuses heavily on the collective effects of genetic variants. I'm not really interested in that for this particular one. Let me see what other titles it has. In short, Wan is a dual-faceted scientist in the evolutionary sphere. He is a contrarian thinker attempting to rewrite how we measure molecular clocks and ancient migrations. In the clinical sphere, he is a practical medical geneticist advancing diagnostic technologies for rare family disorders and parental medicine. Okay, let me go back up here. Something else I wanted to look at here. And then we're going to do the other author, Shi Huang. Yeah, but it's just interesting how they tried to, at least ChatGPT tried to downplay the credentials of these people here, and already we see that the first person is a geneticist. I could have swore ChatGPT said that neither of these were geneticists, and that could very well just be playing into, like I said, the narrative, as I always say. That's why nothing can be taken for face value concerning anything pertaining to the ancient peopling of America, and especially the idea of them being Negroes per se. I'm gonna say, I want to ask, what is the Soltrian model? All right, it says here, the Soltrian hypothesis is an alternative and highly debated archaeological theory regarding the peopling of the Americas, first proposed in the 1990s by archaeologists Dennis Stanford and Bruce Bradley. It suggests that the earliest inhabitants of Americas included European people who migrated across the Atlantic Ocean during the last glacial maximum. Core tenets of the hypothesis. Let me scroll down. Core tenets of the hypothesis. The model challenges the exclusive Bering Strait framework, which states that the Americas were populated solely by Asian populations crossing a land bridge into Alaska by introducing the transatlantic route. The lithic connection. The foundation of the theory is the striking technology similarity between the flint tool napping techniques of the Soltrian culture in Ice Age Europe, modern day Spain, and France, roughly 21,000 to 17,000 years ago, and the Clovis culture in North America, roughly 13,000 to 12,600 years ago. Both cultures utilize distinct, finely flaked bifacial projectile points. The ice bridge route proponents suggest that the Soltrian coastal hunters traveled westward along the edge of the pack ice covering the North Atlantic Ocean using watercraft, eventually landing on the eastern coast of North America. Mainstream scientific consensus versus alternative reinterpretations. The Soltrian model is not accepted by the vast majority of mainstream archaeologists, geneticists, and anthropologists. The scientific community generally rejects it based on several key counter arguments. Timeline. The geographical gap. Mainstream scientists point out significant temporal gaps or a significant temporal gap of roughly 4,000 years between the end of the Soltrian culture in Europe and the appearance of Clovis culture in America. Furthermore, no intermediate archaeological sites or tools have been discovered in the middle of the North Atlantic, such as Greenland or Iceland, to support a stepping stone migration. Mainstream genetic evidence. Decades of robust genetic mapping of ancient modern Native American populations overwhelmingly indicate an exclusive shared ancestry with East Asian and Siberian populations. The genetic history of the indigenous peoples of the Americas is divided into two distinct periods. The initial peopling of the Americas from 20,000 to mainstream ancient DNA studies on famous early American skeletons, such as the 9,500-year-old Kennewick Man, which we're going to get into right now, or the 12,700-year-old Anzac One, which this article also mentions as well, explicitly group them with modern Native Americans and confirmed Asian Siberian lineage, showing no direct link to Western Europeans. All right. Alternative molecular reinterpretations. While mainstream genetics rejects the theory, some alternative evolutionary researchers have attempted to use unorthodox genetic models to revise the debate. For example, a bio-RXIV preprint by Diane Wan and Shi Huang titled Peopling of the Americas, Molecular Evidence for the Paleo-American and the Soltrian models, argued that traditional genetic linear models are flawed because they mistreat saturated phases of genetic mutations. mutations. What does that mean? Saturated phases of genetic mutations. Because they mistreat saturated phases of genetic mutations. So they're naming specific, what what they see or analyze as biased methods or flawed methods of how they're analyzing this DNA, and they named something very specific here. At least Gemini specifically named something specific in method. It says that they mistreat saturated phases of genetic mutations. I'm gonna find out what that means. Well, let me read on. Using their alternative maximum genetic diversity MGD framework, they claim that the Clovis era ANZIC1 genome shared a distinct statistical correlation with El Moran, an ancient European skeleton from the post-Solitarian Magdalenian culture in Spain. Certain rare Native American mitochondrial DNA haplogroups like X2A share slow evolving mutations with European and South Pacific populations, suggesting a complex multi-directional ancestral admixture that included European sea migration. These alternative findings rely on a non-standard interpretation of genetic data and remain outside of mainstream peer-reviewed genomic consensus. Now, already, as I pointed out in prior presentations, I think this was probably the first one I've done on, the first one I did. It was like a PowerPoint presentation where the title was African Americans are not West Africans, and already African American is a misnomer anyway, but I just did it for shock. I titled that for shock value, or whatever. But what's not shock value, or what was not intended to be shock value, is the position that so-called African Americans are not from West Africa. At least that's not their primary ancestry, and which is this whole channel is predicated off of that premises. But here, in that presentation, what I wanted to point out, I briefly used the Malta population as an example of multi-directional, intercourse between population groups, and how they admix together to form later population groups, and what I'm particularly referring to in terms of Malta is that the Malta population contributed DNA input into the early Levant. That population did not make up the entire DNA input for that region, but it played an important role in making up that region that we know now as the Levant, or was known as the Levant. So the idea of multi-directional gene flow is not something that's non-mainstream. It's been documented by mainstream, but not to this extent. They're going in a direction that mainstream science does not agree with. But this channel doesn't really care what mainstream academia has to say. I see mainstream academia as just one source, not the ultimate source. I feel like there is a lot of gatekeeping within mainstream academia, and so therefore there has to be a lot of cross-referencing done with early historians, early anthropology, along with alternative modern articles as this one. And so I wanted to get the question answered. Let's go back up. What is saturated phases of genetic mutations? What is a saturated what did they mean by saturated mutation phases and how could they be mistreated? In genetics and evolutionary biology, a saturated mutation phase occurs when a specific site in the DNA sequence has mutated so many times over evolutionary history that it has run out of new options. Because DNA only consists of four bases: adenine, thymine, cytosine, and guanine. A single position can only change a few times before it inevitably mutates back to a base it used to be, or matches another species purely by coincidence. Interesting. So let me read that again. In genetics and evolutionary biology, a saturated mutation phase occurs when a specific site in the DNA sequence has mutated so many times over evolutionary history that it has run out of new options. Because DNA only consists of four base, okay, I need to repeat that. A single position can only change a few times before it inevitably mutates back to a base it used to be, or matches another species purely by coincidence. When a sequence reaches saturation, the true evolutionary distance between two organisms will become masked. Here is a breakdown of what this means and how traditional genomic methods can mistreat or misinterpret this data based on a framework presented by Zhang Wan and Chi Huang in their papers. In their paper on the Peopling of America's Molecular Evidence for the Paleo-American and the Solitron Model, Understanding Saturated Mutation Phases. Ain't nobody done this, y'all. It might be a little corny to pat myself on the back, man, but I don't think anybody has broken this down, man, on YouTube, man. I think this is exclusive, man. Yeah, I might have to charge for this. But anyway, I'm just joking. Understanding saturated mutation phases. Think of DNA sequence like an odometer on a car, but instead of counting up indefinitely, it resets or randomizes after it hits a certain number. When two species split from a common ancestor, mutations accumulate over time. In the linear phase, the number of genetic differences between the two species is directly proportional to the time that has passed. If species A has 5 differences from species B, they diverge more recently than if they had 50 differences. However, over deep evolutionary time, saturation hits. Multiple hits. A single position might change from ATCA to scientists looking at the DNA today. It looks like a mutation. It looks like no mutation ever occurred, even though it changed 3 times. Convergent mutations. 2 entirely unrelated species might independently mutate into having a G at the exact same position, making them look closely related when they aren't. Oh shit. Oh my god. Oh. Yeah, the DNA groupies gonna be mad about this one. Oh yeah. No wonder they bury these type of articles under the rug, man. They know what they doing, man. They know what they doing. But it's a wrap. Cause I'm on they bumper, man. Yeah, buddy. Wait till I air this one. How saturated phases are mistreated. According to the maximum genetic diversity hypothesis championed by Wan and Huang, Mainstream molecular anthropology fundamentally mistreats this phenomena by applying a linear model to a non-linear reality, treating saturation as time passed. The molecular clock era. Mainstream genetics relies on the molecular clock theory, which assumes that the mutations accumulate at a relatively steady linear rate over time. Wan and Huang argue that researchers often mistake a sequence that is actually in its saturated phase for one that is still in linear phase. When you assume a genetic relationship is linear, you calculate divergence times based purely on the number of differences. But if the sequence has hit a saturation ceiling, the number of differences stops reflecting time. Oh boy. This can cause scientists to wildly miscalculate when populations split, or to assume two groups are unrelated simply because their fast evolving sequences have scrambled and reached maximum diversity. Over relying on fast evolving adaptive SNPs, not all DNA mutates at the same speed. Large proportions of the genome, or fast SNPs, change rapidly because they adapt to changing environments. The authors argue that the mainstream studies treat these fast evolving adaptive SNPs as reliable markers of deep ancestry. In reality, because they adapt quickly, they hit the saturation phase rapidly. Those two groups living in similar environments might share these fast SNPs because of natural selection, not because they share recent ancestors. Conversely, true ancestral signals get completely erased in these regions over thousands of years. Oh, this is groundbreaking. This is about to be a wrap for y'all, man. You know, the suspicion amongst this community, I think, is going to be verified after this presentation is complete. You know what I'm saying? Because now we have a geneticist who has given us the methodology. Yeah, I said it right. The methodology behind how DNA could be misinterpreted or misunderstood or mistreated is the better word. Because mistreated, you know, the word mistreated doesn't necessarily determine whether a person's intent is intentional or they just made a mistake. Even though I'm leaning towards this is an intentional, systematic, implications of how they systematically just say, okay, this is how we're going to mask the DNA. You know what I mean? That's my opinion. But even if you want to be non-subjective about it and you want to be neutral about it, at least they pointed out a specific flaws within methods concerning these DNA results that could yield misinterpreted data, or mistreated data can lead to false results, basically. But let me keep reading. Where we at? Over relying on fast SNPs, the authors argue that mainstream studies treat these fast evolving adaptive SNPs as reliable markers. We read that already. Let me scroll down. How this mistreatment alters history. The paper's argument. Wan and Huang claim that this mathematical mistreatment is exactly why traditional DNA studies conflict with archaeological and skull-shaped morphological data regarding Americas. Pretty much what I just said. And this is pretty much what the community is is feeling. None of us, most of us at least, are not, geneticists. So we can't put our finger on it, man. And you know what I mean? They're dangling this in front of our face like hee hee ha ha. See, this is the traditional Native American, Y and Y DNA and mtDNA. These are not your ancestors, and there was only one people here, you know. And so yeah, they dangle that on, above our head because they know they have the benefit of mainstream academia protecting the narrative. But shout out to these two geneticists, man, for banging for banging for the truth, man. And this particular genetic article or research article is or study, I should say, because this is a primary study. This is not an article. This is a primary study. They're gonna go. So far, they've only mentioned at least Gemini has only mentioned one other, ethnic group, but this paper is gonna go into I ain't gonna give it away, but we're gonna get into it, man, because it relates directly to us. You know what I mean? And yeah, so anyway, I'm just gonna keep reading. Let's go. The author's reinterpretation by hold on, let me not skip something. Yeah, I was at this first paragraph where it read, Wan and Hong claim that this mathematical mistreatment is exactly why traditional DNA studies conflict with archaeological and skull-shaped morphological data regarding Americas, as we all feel. The mainstream view, standard genomic analysis, group ancient skeletons like Kennewick Man and Anzac 1 firmly with modern Native Americans and East Asians because their linear models prioritize genome-wide averages, which are heavily influenced by saturated fast-evolving SNPs. The author's reinterpretation by discarding the scrambled saturated phases and looking only at slow evolving nuclear sequences, which are still in linear phase and retain true historical memory, Wan and Hong reach radically different conclusions. They argue that when you look strictly at unsaturated data, Kennewick Man shows significant archaic African, Neanderthal affinity, and Anzac 1 directly links to Ice Age El Moran genome of Spain, seemingly validating the Paleo-American and Solitron migration models. Kind of gave that away. I didn't want to give it away too quick, but here we go. In short, they argue that mainstream genetics is blinded by genetic noise from saturated mutations, mistaking environmental adaptation and saturated randomness for true ancestral lineages. Bang, bang, bang. Let's go back up here. What else I want to say? I'm going to ask it. Okay, so I want to ask, just so you guys can see and confirm what method the original study of Kennewick Man did. Whether they did slow or whether they did fast evolving at adaptive S&P methods. So, which method did the original Kennewick Man study use to determine his DNA? High throughput genetic sequencing. I don't want to get to the specific question of whether they use did they use the fast S&P method or Did they use the slow S&P method to account for saturation? I am referring to the mainstream results. Oh boy, look what we have here. The mainstream study led by Morton Rasmussen and his team did not use the slow S&P method. The slow S&P method to account for mutation saturation, nor did they explicitly frame their work around distinction between fast and slow S&Ps. Instead, they use what the Yan Wan and Shi Huang define as the fast S&P method, specifically a genome-wide average method. Here is how the mainstream study approached the data and why it forms the core of the disagreement between the groups. The mainstream approach, genome-wide variation. Mainstream population genetics typically relies on evaluating hundreds of thousands to millions of single nucleotide polymorphisms spread across the entire genome to calculate overall genetic affinity. The original 2015 study calculated genetic distances based on all available high-quality genomic data pulled together. This method operates under standard neutral evolution models, assuming that by averaging variations across the whole genome, the dominant signal will accurately reflect the true population history and ancestry lines. That alone sounds biased in the book, man. That sounds tampered, man. Come on, man. Y'all got to get up off us, man. Y'all got to back up off us, man. We gained too much momentum now, man. You know what I'm saying? Like, we starting to get too many people involved in this movement who do understand, or at least have a basic understanding of genetics. I got a scientific background. That doesn't make me a geneticist. You know what I mean? I do have a 4-year degree in science. It's an environmental science, which is more of a general science. However, to obtain that degree, you have to have a certain level of scientific curriculum, chemistry, biology, so forth and so on. So what I'm saying is, I'm definitely not a geneticist. I understand that and I recognize that. However, my understanding of science is not high schoolish. You know what I'm saying? So, and so I'm not bragging on myself. I'm just indicating the fact that, this community is starting to incorporate people of many different disciplines and backgrounds. And everybody has a mind of their own, and everybody is out here searching for the truth, man, in different directions. And we're coming back and we're pulling it together like a community should. You know what I mean? And so we've had the suspicion for a long time of these DNA results being tampered with. Now we have the method. Yeah. It's going down. It's going down, man. So I'm gonna read that over again, man, to make sure we got this understanding. The mainstream approach, genome-wide variation. Mainstream population genetics typically relies on evaluating hundreds of thousands to millions of single nucleotide polymorphisms, S&Ps, spread across the entire genome to calculate overall genetic affinity. The original 2015 study calculated genetic distances based on all available high-quality genomic data pulled together. This method operates under standard neutral evolution models, assuming that by averaging variations across the whole genome, the dominant signal will accurately reflect the true population history and ancestry lines. The critique from Wan and Huang in their paper on the peopling of America's molecular evidence of the Paleo-American and Soul Train models, Wan and Huang explicitly argue that the genome-wide averages are fundamentally flawed because they are heavily weighted by fast-evolving adaptive SNPs. According to their framework, mainstream average, by using a broad sweep of the genome, the mainstream study unwittingly flooded its calculations with saturated genetic noise. Wan and Huang claimed these fast SNPs change rapidly to adapt to local environments. Therefore, Kennewick Man grouped with modern Native Americans in the mainstream study simply because they shared a similar environment or underwent similar regional adaptations, masking deeper ancestral roots. The alternative slow SNPs, Wan and Huang reanalyzed the raw data by intentionally filtering the genome-wide average. They isolated a targeted subset of approximately 15,000 slow SNPs. Summary. Well, let me read this in parentheses. Mutations in highly conserved, slow evolving nuclear sequences, which they argue are still in a linear, unsaturated phase and hold the true historical record of deep ancestry. Summary. The mainstream study used genome-wide averages because standard genomic practices assume that broad genome-wide data provides the most complete picture of relatedness. They did not filter for mutation saturation using a slow SNP framework, as they do not subscribe to the maximum genetic diversity hypothesis. Read that one more time. The mainstream study used genome-wide averages, the fast SNP method, in the context of this debate because standard genomic practices assume that broad genome-wide data provides the most complete picture of the relatedness. They did not filter for mutation saturation using the slow SNP framework, as they do not subscribe to the maximum genetic diversity hypothesis. I ask one more question, and then we're gonna get into Shi Huang's background, and then after that, I'm gonna cut it because this has been a good one, man. I want to make sure I capture, this first part, and I'm gonna call this the intro part 1 or whatever, because this is good, man. I want to make sure this is recorded properly, and I don't want to continue, going on. If it wasn't, man, I have to, double back and redo it, but I think it's captured pretty well here. And so after I read this summary over again, we'll go over Shi Huang's background, and I'm gonna cut it right there, go back and review the information to make sure this came out right, because this take has to be recorded, man, because this is a hot take right here. But again, the summary: the mainstream study used genome-wide averages. I think I just read that already. Averages. I'm gonna read it again. Shit, what the hell? Mainstream study used genome-wide averages, the fast SNP method, in the context of this debate because standard genomic practices assume the broad genome-wide data provides the most complete picture of relatedness. They did not filter for mutation saturation using a slow SNP framework, as they do not subscribe to the maximum genetic diversity hypothesis. So I'm gonna ask, mainstream geneticists mainly use the fast SNP method Okay, it says no, they don't use that method. They don't recognize that method. The specific terminology and unique to the Wan Wan's Chi Huang's alternative maximum genetic diversity framework in the mainstream population genetics. The standard approach is simply called genome-wide analysis or global ancestry modeling. The contrast between how the two camps view the exact same genetic data comes down to fundamental disagreement over how evolution works. Fair enough. The mainstream view genome-wide variation. Mainstream geneticists look at hundreds of thousands of single nucleotide polymorphisms SNPs spread across the entire genome to calculate overall genetic affinity. The logic, mainstream science relies on the neutral theory of molecular evolution. This theory states that the vast majority of genetic mutations have no effect on survival. They are neutral and accumulate at a steady rate over time like clock. The method, by averaging variations across the entire genome, any random noise or localized environmental adaptations are mathematically smoothed out. Oh snap, man. So listen, man. We've used the term smoothed out. Well, I can't say that, people in general have used the term smoothed out. It's a scientific term amongst the academic community. But here, basically what they're saying is that if something might be recognized as something totally different than what it is. So this directly relates to, Black Americans recognizing Black Indigenous ancestry and still being called, people of West African descent because of genetic data, which here it clearly stresses or it indicates that, environmental adaptations can be smoothed out. You know what I mean? So basically, and it says specifically, any random noise or localized environmental adaptations are mathematically smoothed out. So I'm gonna ask it, what would be an example of a smoothed out localized environmental adaptation? The remaining dominant statistical signal is believed to reflect the true unvarnished history of the population splits and migrations. Under this standard model, Kennewick Man and Anzac One group decisively with modern Native Americans and Siberian and East Asian source populations. So my question is this: what would be an example of smoothed out localized environmental adaptations? Okay, it says in mainstream genetics, a smoothed out localized environmental adaptation refers to filtering out genetic noise, specific mutations that change rapidly because the population was adapting to local climate, diet, or disease to uncover the true deep ancestral tree. When mainstream genetics looks at ancient DNA, they look at a genome-wide average of hundreds of thousands of SNPs. They do this because looking at just a few genes can give a completely false picture of who is related to whom. Here are two clear examples of how localized environmental adaptations can distort ancestry and how mainstream methods smooth them out to find the truth. Example 1, the high altitude adaptation, Tibetans versus Han Chinese. The localized adaptation, people living on the Tibetan plateau possess a specific variant of the EPAS1 gene, often called the athlete gene, which allows their blood to cope with highly limited oxygen at extreme altitudes. The potential error: if a geneticist evaluated only the EPAS1 gene region, a Tibetan individual would look incredibly distant from the lowland and Chinese individual. In fact, because Tibetans inherited this specific variant from interbreeding with ancient Denisovans thousands of years ago, looking only at this localized adaptation might make them look more closely related to Denisovans than to modern Asians. So, with that same point, it seems as though, DNA results can be manipulated in one direction or the other. You know what I mean? If they want to pinpoint certain mutations and say that this population group is more distant than the other, they can. If they want to ignore it to bring more affinity between two groups, they can. You know what I mean? So the DNA groupies who always want to say, because mainstream academia said this, it has to be, they deserve some challenging because of methods. You know what I'm saying? And then we're seeing it right here. But anyway, it points out the Pacific era there. Let's read on. How it is smoothed out. Mainstream geneticists do not look at EPAS1 in isolation. They average it alongside 500,000 other neutral SNPs across the entire genome. Because the other 99.9% of the genome shows a massive shared genetic footprint, the single spike of the high altitude adaptation is mathematically smoothed out, correctly revealing the Tibetans and Han Chinese split from a very recent common ancestor. Okay. The Maasai versus Europeans. All right, let's check this out. Lactase persistent, Maasai versus Europeans. The localized adaptation, the ability of adults to digest milk. Lactase persistence evolved rapidly and independently in populations that took up dairy farming.